Explain the AI black box in IFU regulatory grade English. Welcome! Today we're demystifying AI in healthcare by explaining the so-called black box. Clear explanations aren't just nice to have. Regulators require transparent behavior so safety can be verified. Users also need to predict what the device will do in real situations, when it analyzes, when it alerts, and when it stays quiet. That clarity prevents surprises, reduces misuse, and limits liability for your organization. Think of it like a pilot's checklist. Everyone knows the steps, limits, and expected outcomes. When the system is explainable, trust increases, adoption improves, and issues get caught before they become incidents. You don't need to expose source code. Instead, define the algorithm's purpose and inputs in plain English. For example, this tool estimates pneumonia risk using chest X-rays, vitals, and age. Next, describe outputs and decision boundaries. Outputs a risk score from 0 to 1. Above 0.7 triggers a high-risk alert. Then map the data flow step by step. Images uploaded, quality checked, pre-processed, scored, and returned to the EHR. This tells regulators and users exactly what the system evaluates, how it decides, and what they'll receive, without diving into code or proprietary details. Say clearly whether your model is static, fixed after approval, or adaptive. Updates after deployment. If adaptive, list what can change. For instance, thresholds, calibration, or feature weights. And what cannot, such as medical indications or excluded populations. Name the guardrails: human review before promotion, automatic rollback on degraded performance, and audit logs. State the update frequency. Monthly recalibration using de-identified local data. Major model retrains only annually with validation. This helps users understand stability versus evolution and shows regulators you manage change with discipline. Spell out the triggers that make the algorithm act. Example: runs on new lab results, new radiology images, or a clinician request. For each trigger, define the expected response. Calculates a risk score within 30 seconds and posts an alert. Include limits and thresholds. Alerts fire at scores is greater than or equal to 0.7. Repeat alerts suppressed for 4 hours. Add fallback behavior. If image quality is low, the system withholds results and prompts a retake. If service is down, the EHR displays the last valid score with a timestamp. Clear triggers and responses prevent confusion and alarm fatigue. Report performance across typical, challenging, and failed conditions. Example: typical, clear images, complete vitals, AUC 0.90. Challenging, motion blur or missing vitals, AUC 0.82 with higher uncertainty. Failed, unreadable images, no score returned. Provide accuracy ranges with scenarios. High-risk alerts are correct, 88 to 92% in ICU patients, but 80 to 85% in emergency triage. List known risks, e.g., reduced accuracy in pediatrics, and mitigations in the IFU. Population flags, uncertainty warnings, and required human confirmation before acting on borderline results. Define what humans must do. User checks, verify patient identity, data quality, image clarity, correct units, and clinical plausibility of outputs. Overriders stop when alerts conflict with strong clinical evidence, when inputs are incomplete, or when the system shows abnormal latency or error rates. Provide escalation steps. Document the issue in the record, notify the AI support team, switch to standard of care protocols, and file a ticket with logs and timestamps. Clear documentation keeps accountability traceable and supports root cause analysis if anything goes wrong. Write in simple, testable statements. The model returns a score within 30 seconds is better than quickly. Avoid vagueness. Quantify whenever possible. Thresholds, time limits, confidence ranges, and sample sizes. Replace fuzzy words like robust or state-of-the-art with measurable claims. Define all acronyms and technical terms at first use. AUC, area under the curve. EHR, electronic health record. Use consistent terminology across documents. If a tester can check your sentence with data or a stopwatch, your language is probably regulatory grade. Use this lightweight structure. 1. Purpose right pointing arrow. Inputs right pointing arrow. Outputs right pointing arrow limits. What the tool does, what it needs, what it returns, and where it must not be used. 2. Adaptation. Define scope of changes, triggers for updates, validation steps, and safeguards like rollback and human sign-off. 3. User actions. Steps before use. Verify data. During use. Interpret score with context. And after use. Document action. Report anomalies. Fill this in for any model to create a clear, regulator-friendly, and user-friendly explanation. No source code required.